Okay, this is the final exam for Calc 2 of spring 2022. We will get 2 hours on this exam. Compute the following integral. We can see here, we can use integration by parts, L-I-A-T-E. U is whatever comes first. So we can set u is equal to t squared. Therefore, du will be equal to 2t dt. That means dv will be equal to cosine 2t dt. The antiderivative of cosine 2t will be equal to sine 2t divided by 2. Now applying our integration by parts, we will get t squared sine of 2t divided by 2 minus the integral. Notice this 2 and this 2 will cancel. Therefore, we'll just have t sine 2t dt. And we should probably write this, our bounds, or the limit of integration. Here, we can notice this part right here will be equal to 0. Because when you plug in 2 pi and 0 into t, you will get 0. So we can ignore this, basically. Now we still need to worry about this side. Here we can apply integration by parts again. U is equal to t. Du will be equal to dt. dv will be equal to sine of 2t dt. Now our antiderivative of this, antiderivative of sine is going to be a negative cosine. 2t divided by 2. Divided by derivative of what's on the inside, which is 2. Now, we can't forget the negative sign here. We need to distribute this in a second. Applying our integration by parts, we're going to get negative t times cosine 2t, all divided by 2. Now we're going to have a minus integral, but notice this negative and this negative will make a positive. So let's just write plus. Notice this 2 is a constant. We can bring that on front as a 1/2. The integral of cosine 2t dt. Distributing this negative n, we will get t cosine 2t divided by 2 minus, distributing this negative n, we can't forget that, minus a 1/2 cosine 2t, the integral of this we said earlier will be sine 2t divided by 2. And we will be evaluating this from 0 to 2 pi. So plugging this in, we're going to get 2 pi divided by 2 times cosine 4 pi minus 1/2 sine of 4 pi over 2. This entire thing minus, notice when we plug in 0, we're going to get 0 minus 1/2 sine of 0 divided by 2. Simplifying this a little bit further, we notice that cosine of 4 pi is going to be equal to 1. So we have 2 pi divided by 2 minus this thing right here. Sine of 4 pi is 0, so we're going to have minus 0 minus 0 minus 1/2 sine of 0. The y value as 0 is 0. So we can see that every single thing is basically 0, and the thing we're left with is 2 pi over 2, which is equal to pi. Here, this is a very basic, you should immediately be able to tell this is a partial fraction decomp. X plus 3 over x squared minus 5x plus 6. This will be equal to x plus 3. What are two numbers that add up to be negative 5 but multiply to be positive 6? That would be x, well, it would be a 3 and a 2. Or negative 3, negative 2, sorry. Like this. Therefore, this will be equal to a over x minus 2 plus b over x minus 3. Now, if we multiply everything here by x minus 2 times x minus 3, we will end up with x plus 3 will be equal to a times x minus 3 plus b times x minus 2. Now, setting x is equal to, let's say 3. We're going to get 6 plus, we're going to get 6 will be equal to b. So b is equal to 6. Now if we set x is equal to 2, we will get 5 is equal to negative a. Therefore, a will be equal to negative 5. From here, we can put it under the integral sign. Negative 5 over x minus 2 plus b, which is 6 over x minus 3 dx. This is a very basic integration. You can set the bottom as u if you want to, but this will just be equal to ln absolute value of x minus 2 plus 6 ln of absolute value of x minus 3 plus c. And this should be your answer. Solve the following differential equations. We can see here, because it's in the form of this, we can take this, multiply by this, and this, multiply by this. They call it cross multiplication, but basically what you're doing is taking dx, multiply it over, and taking e to the y, and multiplying over to the other side. So you get e to the y dy will be equal to sine squared x cosine x dx. Now if we integrate both sides, we can see the left side is very easy. The left side will just be e to the y will be equal to the right side. How do we do this right side? Notice the derivative of sine is equal to cosine. So let's set u is equal to sine. Therefore du will be equal to cosine dx. We can see this cosine and this cosine will cancel when we solve for dx and plugging it in. Therefore this will be equal to the integral of sine squared, but sine we set as u, so it's going to be u squared du. This will be equal to u to the third power divided by 3 plus c. We started with x, now we're in u, so we need to replace u with what it is, which is sine x. So this is going to be equal to sine cubed x divided by 3 plus c. And all of this will be equal to e to the y. So our final answer will be e to the y will be equal to sine cubed x divided by 3 plus c. You can solve for y if you want to, just take ln of both sides, but there's no need here. So we just did a differential equation, a separable. Now we're probably going to have a linear, because there's linear, separable for these quizzes. Or I mean for these tests, there's always one of each. So here we're going to have it linear. Our integrating factor is here. It's this thing right here. It's whatever it's in front of the y. We have to notice this is by itself. If this has an x, we need to divide everything by x, but it doesn't. So this will just be our integrating factor. So we will have e to the power, e to the power of, we're going to bring the 4 on front because it's constant, x to the third power dx. This will be equal to e to the 4, x to the third power divided by, the integral of that is going to be x to the fourth power divided by 4. Notice this 4 and this 4 will cancel, leaving us with e to the x to the fourth power. We can set this as mu. Now we will have mu times y prime, which is dy dx, plus mu times 4x to the third power times y will be equal to 2x to the third power times mu. Make sure we multiply every single term by mu. Don't forget. Applying the knowledge of reverse implicit differentiation, we can see that this jumble mess right here will be equal to mu y. If we take this will be the derivative, and we can integrate this, dy will be equal to this side, integral of this side, which will be integral. We can notice this 2 is a constant, so we can bring that on front. Integral of x to the third power times mu dx. The integral of a derivative is just whatever it's on the inside. In this case, it'll be mu times y. And remember, mu is equal to e to the x to the fourth power times y will be equal to 2. Let's write this as 2 and then x to the third power times e to the x to the fourth power dx. So, how do we solve this? Realize that x to the fourth power, if you take the derivative, it's going to be equal to x to the third power, basically. So if we set u is equal to x to the fourth power, du will be equal to 4x to the third power dx. Solving for x, we will take this and divide it on the other side, getting dx will be equal to du divided by 4x to the third power. Notice this x to the third power and this x to the third power will cancel. And bring this 4 in front, because it's a constant, we're going to get 2 over 4, which is going to be 1/2. The integral of e to the x to the fourth power. We set that as u. So it's just e to the u power du. Now this is very basic. I wrote this wrong, sorry. Will be equal to 1/2 derivative, or I mean, the integral of e to the u will be e to the u. And we set u as x to the fourth power. Don't forget the plus c. Now we're given an initial value. So let's solve this. When x is equal to 0, y is equal to 4. So when x is equal to 0, so we're going to have e to the 0 to the fourth power, y is equal to 4. So times y, which is 4, will be equal to 1/2 e to the 0 to the fourth power plus c. Notice that 0 to the fourth power will be 0, and anything to the 0 power is 1. In this case, e to the 0 power will be 1. So 4 will be equal to 1/2 plus c. Therefore, we can conclude that c will be equal to 4 minus 1/2, which is going to be 3.5. Or you can write this as 7 divided by 2. Now plugging in what we know for c, y will be equal to 1/2 e to the x to the fourth power plus 3.5, or 7 divided by 2. Take this entire thing, multiply by 1 over e to the x to the fourth power. And this will be our answer. Determine whether each of these following series are convergent, conditionally convergent, divergent, or absolutely convergent. So looking at this, you may be a little scared. This may look a little bit complicated, but they're just trying to trick you here. Or they're not really trying to trick you here, actually. This is a very basic limit comparison once you realize. The trick to limit comparison is if you have a polynomial divided by a polynomial, you can almost like all the time use limit comparison. So we have to say limit comparison, all terms are positive. A of n and b of n are greater than 0. Just saying all terms are positive. And our a of n term will be equal to 4. This is really weird. I don't know why they wrote it like this. N squared times n to the 1/2 power is going to be n to the 2.5 power plus 3n plus 6 all over 2n to the fourth power plus 5 ln n plus square root of n. We can set b of n be equal to 1 over. The thing I like to do on these is I take the highest power on the bottom, subtract it from the highest power on the top. So we're going to get 4 minus 2.5, which is going to be 1.5, n to the 1.5. Now applying limit comparison, the limit as n goes to infinity of a of n divided by b of n will be equal to the limit as n goes to infinity of 4n to the fourth power plus 3n to the 2.5 power plus 6n to the 1.5 power. This will be all divided by 2n to the fourth power plus 5 ln n plus square root of n, which is going to be n to the 0.5 power. We can see here, if we multiply both the top and the bottom by 1 over n to the fourth power, we will end up getting the limit as n goes to infinity of 4 plus 3 divided by n to the 1.5 power plus 6 divided by n to the 2.5 power, all divided by 2 plus 5 ln n divided by n to the fourth power plus 1 divided by n to the 3.5 power. This will be, this term will go to 0, this term will go to 0, this term will go to 0, this term will go to 0. So we're going to end up with 4 over 2, which is equal to 2, which doesn't equal to 0. Therefore, we can conclude because the summation of 1 over n to the 1.5 power will converge by p series, where p is equal to 1.5, which is greater than 1. Therefore, a of n which is all this. I don't want to write all that, so a of n will also converge by limit comparison. And because we said all terms are positive, this will converge absolutely because all terms are positive. Okay, looking at something like this, we can think of ratio test or root test, but in this test, or in this case, we'll use the ratio test. So applying ratio test, we're gonna have the limit as n goes to infinity, the absolute value of n plus 1 over a of n. This will be equal to the limit as n goes to infinity of, we can ignore the negative 1 to n because it's absolute value, and that's just going to be 1, which is not going to affect anything. So we're going to have n plus 1 factorial divided by e to the n plus 1 times e to the n divided by n factorial. This will be equal to the limit as n goes to infinity. We notice we don't have any x's, so we don't need the absolute value anymore. Also, you have to know that n plus 1 factorial is equal to n plus 1 times n factorial. You can pick off terms. Therefore, replacing this with this, we can see that the n factorial and this will cancel. So we will just have a n plus 1 on top. E to the n power will cancel with one of the e to the n's, therefore leaving us with 1 e to the n left on the bottom. And I said we can drop off the absolute value sign. So this will be equal to, wait a second, I did not do this right. Sorry, yes, e to the n, this e to the n will cancel with e to the n, leaving us with just e, not e to the n, sorry. So we will get this. This will be equal to infinity. We can conclude that infinity is always greater than 1, obviously. Therefore, by ratio test, the series is divergent because it's greater than 1. Okay, this one is a little bit more challenging in the sense that we need to write a lot more stuff to prove that we can use tests we want to. Let's call this the OG series, the original series. And we can state alternating series test. So for alternating series tests, 4 conditions needs to be met for it to be convergent. The first being it needs to be decreasing, it needs to be continuous, it needs to be positive, or b of n needs to be positive, and the limit as n goes to infinity of b of n must equal to 0. If all 4 of these conditions are met, then the series will be convergent by alternating series test. To prove this, let's write b of n will be equal to n squared divided by n to the 3rd power plus 7. How do we prove that this is decreasing? We can prove this is decreasing by taking the derivative and setting it less than 0. Because if the derivative is negative, that means f is decreasing. So let's let f of x be equal to x squared divided by x to the 3rd power plus 7. If we take this and take the derivative, we're going to get f prime of x will be equal to, applying the quotient rule, the way I remembered it was ho d high minus high d ho divided by ho squared. So ho is bottom, ho d high times derivative of the top, 2x, minus high d ho, which is x squared, times derivative of the bottom, which is going to be 3x squared. This will be all divided by ho squared, which is the bottom squared. Simplifying this a little bit further, we can get 2x to the 4th power plus 14x minus 3x to the 4th power. This will be all over x to the 3rd power plus 7 squared. Notice this can be simplified a bit further. We're going to get 14x minus x to the 4th power. all divided by x to the third power plus 7 squared. So notice that for when x is greater than or equal to 3, because we're starting at 3, if we square both sides, we're going to get x to the third power is greater than or equal to 27. And looking at this, 14x minus x to the fourth power, this is equal to, picking out an x, we're going to get x, 14 minus x to the third power. So we can conclude that 14 minus x to the third power is less than 0. That is for when x is greater than or equal to 3, f prime of x will be less than 0. You can plug it in here. For any value of x that is greater than 3, we will see this value right here be less than 0. Therefore, f is decreasing, meaning that b of n plus 1 is going to be smaller than b of n. So we know it's decreasing, we know it's continuous, and now we can say the limit as n goes to infinity of b of n, which is going to be n squared divided by n to the third power plus 7. Multiplying the top and bottom here by 1 over n to the third power, we will end up with the limit as n goes to infinity of 1 over n divided by 1 plus 1 divided by n to the third power. We can see here this term will go to 0, this term will go to 0. We're going to have 0 divided by whatever, which is 0 divided by 1 actually, which is going to be equal to 0. So we see this is true and this is true. Since all four of these conditions are met, the original series will converge. Now we need a test for absolute convergence or conditional convergence. To do this, we need to do this. The summation as n goes to -1 to the n, take the absolute value of this, squared over n to the third power plus 7. This will be equal to summation as n equals 3 of n squared over n to the third power plus 7. We can see from just looking at this will diverge by limit comparison test. But to show why it diverges, we need to say a of n is equal to n squared divided by n to the third power plus 7. And therefore b of n will be equal to, take the highest power on the bottom, subtract it from the top, 3 minus 2 is going to be 1. So we're going to have 1 over n to the first power, which is 1 over n. And we need to say a of n and b of n are both greater than 0, meaning they're both positive. That's the only condition we need to say for limit comparison test. Now let's apply limit comparison test. The limit as n goes to infinity of a of n divided by b of n will be equal to the limit as n goes to infinity of a of n, which is n to the third, or n to the second power. Take b of n, flip it over, we're going to get n to the third power over n to the third power plus 7. This will be equal to, actually let's do 1 over n cubed times 1 over n cubed. This will be equal to the limit as n goes to infinity of 1 over 1 plus 7. Sorry, 1 over 1 plus 7 divided by n to the third power. This term will go to 0. Therefore, we can see here, this will be equal to 1, which doesn't equal to 0. So by limit comparison test, because 1 over n diverge by harmonic series. Sorry, this is a squared. This will also diverge Therefore, this will also diverge by limit comparison test. So we can see that this is the original series, the OG series, is conditionally convergent. Drink some water. Find the third degree polar or Taylor polynomial about x equals 3 and f of x equals x times e to the x. F of x is equal to x times e to the x. Therefore, f prime of x, applying our product rule, first time derivative of the second, it's going to be e, or meaning x times e to the x, plus the second, which is e to the x times derivative of the first, which is just 1. F double prime of x will be equal to x e to the x plus e to the x plus e to the x. And this pattern will repeat, so on. Be equal to x e to the x plus e to the x plus e to the x plus e to the x. So f of 3 will be equal to 3e to the x. Sorry, 3e to the third power. F prime of 3 will be equal to 3e to the x plus e to the x, which is going to be a 4e to the x, which is going to be 3. So f double prime of 3 will be equal to 5e to the 3. And this pattern will repeat. 6e to the 3. From this, we can say in general, f to the n of 3 will be equal to a n plus 3 times e to the third power. Would this make sense? This would make sense because if you plug in, this is to the third power, where this is f triple prime. So if you plug in 3 in here, you will get 6 times e to the third power. So this is correct. And we know that this Taylor series is in the form of this. F of n of a divided by n factorial times x minus a to the n power. So we can conclude that the Taylor polynomial, the third degree Taylor polynomial, will be equal to, plugging in 0 for n, we will get just this part right here. Every other part will be equal to 1. Just this part right here, we will see that this is equal to 3e to the third power. 3e to the third power. Plus, plugging in n equals 1, this will be 1, and this will just be x minus a. So we'll have 4e to the third power, 4e to the third power, times x minus a, which is going to be 3. This will be plus, now we have 5e to the third power, divided by, plugging in 2, we're going to get 2 factorial, which is just 2. And x minus a, which is 3, squared, plus 6e to the third power, divided by 3 factorial, times x minus 3 to the third power. And this is our third degree polynomial. Notice that if we factor this out, we're going to get x to the third power as the first term. Where it may be a coefficient, but it'll be x. We'll have an x to the third power. Therefore, this tells us that we can stop here. Compute the first 3 non-zero terms of a Taylor polynomial of cosine x squared. We know that cosine x is equal to, oh my goodness. We know that cosine x from our equation sheet will be equal to -1 to the n, and then it will be a x to the 2n divided by a 2n factorial. Plugging in plugging in n equals 0, we will get -1 to the 0 power, which is 1. So we're just going to positive, and then x to the 0 power, anything to the 0 power is 1. So we're going to get 1, and then minus, because once we plug in 1 for n, -1 to the 1 power is going to be negative. And plugging in 1 for n, we will get x squared divided by 2 factorial, which will just be 2. Plus, plugging in 2 for n, we will get x to the 4th power divided by 4 factorial. Plus dot 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 and so on. This is the first 3 term of non-zero, so we can stop there. Now, we need a cosine x squared. Let's just replace every x we see with x squared. Therefore, we're going to get 1 minus x squared is going to be x to the 4th power divided by 2, plus x squared to the 4th power is going to be x to the 8th power divided by 4 factorial, plus dot 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 and so on. Now we can approximate this. We can approximate the integral from 0 to 1 of cosine x squared dx. This will approximately be equal to the integral from 0 to 1 of 1 minus x to the 4th power divided by 2 plus x to the 8th power divided by 4 factorial dx. This is a very basic integration. This will be equal to x plus x to the 5th power divided by 10 plus x to the 9th power divided by 9 times 4 factorial. Evaluating this from 0 to 1, we will get 1 plus 1 over 10 plus 1 over 9 times 4 factorial. We don't need to worry about the 0 term because when we plug in 0, we're going to get 0. So this is our answer. Find the Taylor series about x equals 0 and f of x is equal to this. So, how would we do this? Let me think. Okay, so we know that 1 over 1 minus x, this is a very basic geometric series thing, will be equal to x to the n power. So therefore we can conclude that 1 over 1 minus x squared will be equal to the same thing basically, but every single x we see, let's replace that with x squared. So we're going to get x squared times n, where x squared to the n power. So if you have an exponent to another exponent, you multiply them. So you're going to get x to 2n. Now if you have an x, 1 minus x squared, this will be equal to x to the 2n times x is simply equal to x to the 2n plus 1. And that's all the work we need to show for this one, I believe. Use Taylor series to compute this. The trick about this is we have to realize this power and this power is the same thing. After you realize this becomes a very easy question. Let's combine the bases. Combining the bases, we're going to get pi divided by 4, 2n plus 1. And this will be all divided by 2n plus 1 factorial. From here, we can look on our equation sheet for something that looks like this. And we can notice that sine. Notice sine x is equal to -1 to the n x to 2n plus 1 over 2n plus 1 factorial. We can see the only difference between these two is that x is replaced by pi over 4. Therefore, we can say x will be equal to pi over 4. If x is equal to pi over 4, sine of pi over 4 will be our answer. Sine of pi over 4 is 45 degrees, which is this right here. The y value here is going to be a radical 2 divided by 2. So our answer will be equal to radical 2 divided by 2. Consider the series. Determine the radius of convergence of the series. When we see this, we always want to think about ratio test. So let's apply ratio test. The limit as n goes to infinity of a of n plus 1 divided by a of n will simply be equal to the limit as n goes to infinity of the absolute value of x minus 4 to the n plus 1 divided by n plus 2, but n is equal to n plus 1. So n plus 1 plus 2 is going to be n plus 3 times n plus 2 all over x minus 4 to the n power. This will be equal to the limit as n goes to infinity. This term and this term will cancel, leaving us with x minus 4 on top times n plus 2 all divided by n plus 3. Bring the constant in front, we're going to get this is going to be equal to the absolute value of x minus 4. The limit as n goes to infinity of n plus 2 over n plus 3. Multiplying both the top and bottom by 1 over n, we will get the absolute value of x minus 4, that stays. The limit as n goes to infinity of 1 plus 2 divided by n, all divided by 1 plus 3 divided by n. We can see this will be equal to x minus 4, the absolute value of x minus 4. And for this to be convergent by ratio test, this needs to be less than 1. So we can see our radius of convergence is going to be equal to 1. Determine the interval of convergence of the series. The interval of convergence, we have to realize the absolute value of x minus 4, the absolute value is a piecewise function with two pieces. One of the pieces is going to be x minus 4 will be less than 1. The other one will be negative x plus 4 will be less than 1. Now solving this, we're going to get x is less than 5. Solving the second one, we're going to get negative x is less than negative 3. Therefore, x is going to be greater than 3. So we have 3 is less than x is less than 5. We need to test the endpoints to see if this is convergent, or if the series is convergent or divergent at the endpoints. So let's test x equals 3. Plugging x equals 3 in, we will see we're going to have a 3 minus 4, which is negative 1. So we're going to have a negative 1 to the n power divided by n plus 2. Here we can see this is a convergent by alternating series test. And to prove this, we already know it is, but to show a little bit of work, and we need to say 4 different things for alternating series test. B of n must b of n, if b of n is equal to 1 over n plus 2, it needs to be continuous, decreasing, because the denominator is increasing. Continuous, decreasing, because the denominator is increasing, and it needs to be positive, so b of n must be greater than 0, and the limit as n goes to infinity of b of n must be equal to 0. 1 over n plus 2 must be equal to 0. Since all 4 of these conditions are true, this series will converge by alternating series test. Let's plug in x equals 5, the other endpoint. We will get a 5 minus 4, which is just 1. So we're going to get 1 over n plus 2. 1 over n plus 2. If we set a of n is equal to 1 over n plus 2, and b of n is equal to 1 over n, and we say all terms are positive, all terms positive, meaning a of n and b of n are both positive, we can apply limit comparison. Applying limit comparison, the limit as n goes to infinity of a of n divided by b of n will be equal to the limit as n goes to infinity of n divided by n plus 2. Multiplying both top and bottom by 1 over n, we will end up with the limit as n goes to infinity of 1 divided by 1 plus 2 divided by n. We can see this term will go to 0. Therefore, the limit as n goes to infinity sorry, we don't need to write this again. This will be equal to 1, which doesn't equal to 0. So since this doesn't equal to 0, we can say because 1 over n diverge by harmonic series, a of n, summation of a of n, n plus 2, will also diverge by limit comparison. So we can conclude that when x is equal to 3, the series will converge. So we write square brackets 3. And when x is equal to 5, the other endpoint, this will diverge. And this is our interval of convergence right here. Find the center and radius of the sphere. This is a very, very basic, what is it called? Complete the squared? Complete the square. If you get this on the test, it's basically 3 points. If you know how to do complete the square. X squared, let's group all the terms together. X squared plus 4x plus y squared minus 6y plus z squared plus 10z will be equal to 11. So x squared plus 4 divided by 2 is 2. 2 squared is going to be 4, so we'll plus 4. Plus y squared. 6 divided by 2 is 3. 3 squared is going to be equal to 9. Plus 9. Plus z squared plus 10z. 10 divided by 2 is 5. 5 squared is going to be 25. 11 plus, let's write this over here so we have more room. 11 plus a 4, a 9, and a 25. If we add it to one side, we must add it to both sides. Notice 11 plus 9 is equal to 20. 20 plus 4 is equal to 24. 24 plus 25 is 1 less than 50, which is 20, which is 49. So this right here is equal to 49. Now all of these are perfect squares. So we're going to have x plus 2 squared plus y minus, sorry, this is a minus 6. So we're going to have a y minus 3 squared plus a z minus, actually it'll be a z plus 5 squared will be equal to 49. So our center is going to be -2, 3, and -5. And our radius will be equal to square root of 49, which is equal to 7. Let a be this, b be this, and c be a minus c. Find the angle between vectors a and c. So, if we need to find the angle between a and c, we can say that a dot c will be equal to the magnitude of a times the magnitude of c cosine theta. So therefore, theta, solving for theta, we will get arc cosine of a dot c divided by absolute value of a times the absolute value of b. C. Not absolute value, the magnitude. So, we need to find what c is first. To find c, c is equal to a minus b. This is going to be equal to a, which is going to be 3, -1, minus b, which is equal to 5, -5. We can see here, this will be a 3 minus 5, which is going to be a -2. -1 minus -5 is going to be -1 plus 5, which is going to be -4. Wait, no. It's going to be a 4. Just a 4. Sorry. Now, let's compute 8.c. 8.c. A.c will be equal to 3, -1, dot, -2, 4. This will be equal to 3 times negative 2, 3 times negative 2, plus negative 1 times negative 4. Sorry, times just 4, sorry. This will be equal to negative 6 minus 4, which would be equal to negative 10. Now let's compute magnitude of A. This will be equal to square root of A is 3, negative 1. So it's going to be a 3 squared plus negative 1 squared, which will be equal to 9 plus 1, which is 10. Now let's calculate the magnitude of C. Magnitude of C is going to be equal to the square root of negative 2 squared plus 4 squared, which will be equal to 4 plus 16, which is going to be 20. So plugging everything we know here into this formula, we're going to get theta is equal to arc's cosine of A dot C, which we said was negative 10, all over magnitude of A, which is radical 10, square root of 10, times magnitude of C, which is square root of 20. And this will be our answer. Consider the points A, B, and C. Find the equation of a plane that contains A, B, and C. To find the equation of a plane, we need our normal, and we need a point. We have a lot of points here, so let's just say our point is equal to 1, 4, 2. How do we find n? This will be equal to, let's say, v cross a w. Now what is our v? Our v will be equal to, we're given 3 points. We need 2 vectors, a, b. This will be equal to b minus a, which will be equal to, b is 2, 0, negative 1, minus a, which is 1, 4, 2. This will be equal to 2 minus 1, which is going to be 1. Negative 4 and negative 1 minus 2 is going to be a negative 3. And our w, we can say that is equal to ac, which will be equal to c minus a, which is equal to 310 minus 142. This will be equal to 3 minus 1 is going to be a 2. 1 minus negative 4 is going to be a negative 3. 0 minus 2 is going to be a negative 2. Now we can find n. N will be equal to v cross a w. A cross product of 2 vectors will give us a vector. This is what we need. This will be equal to I, j, k, 1, negative 4, negative 3, 2, negative 3, 2, negative 2. This will be equal to I, negative 4, negative 3, negative 3, negative 2, minus j, 1, negative 3, 2, negative 2, plus k, 1, negative 4, 2, negative 3. This will be equal to negative 4 times negative 2 is going to be 8, minus a positive is going to be 3 times 3 is going to be 9. So it will be 8 minus 9 minus a j. 1 times negative 2 is going to be a negative 2. 2 times a negative 3 is going to be a negative 6. Negative 6, so we'll have a negative, will be a minus a negative, which would be a positive 6, plus k. 1 times negative 3 is going to be a negative 3. 2 times a negative 4 is going to be a negative 8, minus a negative 8 is going to be a plus 8. So this will be equal to negative 1, negative 4, and this will be a positive 5. So writing our equation of the plane, we're going to have negative 1 times x minus our point, which is, let's set our point as a, which is 1, 4, 2. 1, 4, 2. This is our point. Minus 4. And then this will be y minus our point, which is 4. Plus 5. Z minus our point, which is 2. And this will be equal to 0. And that will be our answer. Find the equation of the line perpendicular to the plane you found that passes through point A. So since it's perpendicular, our direction vector will be equal to n. Therefore, the equation of the line perpendicular for a line, we will have x, y, z. This will be equal to a point. Any point, we can just use 8, right? Which is 1, 4, 2 from what we said earlier. Plus, now we're going to have t times Rn. N is going to be negative 1, negative 4, and 5. And this is our answer. And that's it.